Hi, grade 11 students. Our study today is to solve trigonometric equations. I'm going to start by the first property. When 2 cosine x equal cosine a. Suppose I want to solve for x. I want to find the angle that makes cosine x equal cosine a. So if I go to the trigonometric circle, cosine is the x-axis, as you all know. If you pick any point on the x-axis, we need to find angles such that it will give me this cosine, or the projection on the x-axis will be from this point till that point. So I draw a horizontal line, a vertical line. So these two values will give me the same cosine, the same intersection with the x-axis. So if this angle is alpha, the opposite one will be minus alpha, and here if it's alpha, the opposite one will be minus alpha. If you have here also, you draw a vertical line. If this is alpha, the opposite one will be here negative minus alpha. So that's why I have the property. This is in radian, this is in degree. 360k or 2k pi, it means many rotations. Let us go to application. I have the boundary given. I want to find x between minus pi and pi, so that 2 cosine x minus 4 is 0. So if I solve for cosine x, I have half remarkable angle, which is cosine 60 degree. So cosine x equal cosine pi over 3. If I apply the property, x will be equal pi over 3 plus 2k pi, or pi minus pi over 3 plus 2k pi. So if k is 0, I have pi over 3 and minus pi over 3 in the boundary. If k is 1, or what, you're going to get 2 pi plus pi over 3 outside the boundary, rejected. And here also, if k is 1, 2 pi minus pi over 3, rejected. If k is minus 1, also minus 2 pi plus pi over 3, also rejected. Whatever k you're going to take, all will be rejected except for k is 0. So these are the two solutions. Let us take another example. Here I have another equation. So I take the 2 to the other side. I divide it by 4. I have the square. If I remove the square, I put a plus or minus 1 over radical 2, which is radical 2 over 2 plus or minus. So I start by the first one. Which cosine will give me 1 over radical 2 or radical 2 over 2 is 45. So I apply the property. So here I don't have any more x. I have expression 2x minus 30 equal to 45 plus 360k, or 2x minus 40 minus 30 equal minus 45 plus 360k. So I take the minus 30 to the other side, then I divide the whole expression by 2. I'm going to get these values of x. So now I start by taking values of k, 0, k plus or minus 1, k plus or minus 2. The angles that I need to have, it must be between the boundary I gave you. So if you start by k is 0, both works here. If k is 1, you replace here 180 plus this angle and 180 minus this angle. These two angles are in the boundary. If k is minus 1, the first one here, if you replace k by minus 1, this is the angle accepted here. If you replace by k is minus 1, you're going to get minus 187.5. It's rejected because minus 187.5 is not in the boundary. So here rejected. If you continue k of 2 or minus 2, all angles after that are all rejected. So for this expression, you have minus radical 2 over 2. This is cosine of 135. You need to know this angle, these remarkable angles. So as I did up, I put 135 minus 135. So I solved that system. I'm going to get, you can check it by yourself. I'm going to get this one. So I start, if k is 0, both are accepted. If k is 1 here or here, so 180 plus this angle or 180 minus this angle, both are in the boundary. If k is minus 1, so the first one will give me this angle accepted. The second one, it will give me this one, which is rejected. And any k outside more than for 2, minus 2, whatever, 3, minus 3, all are rejected. Here I have another property for sine. When two sines are equal, for sine, let us pick any angle here, for example, in the sine axis. Which angles will give me the same sign? If you draw now a horizontal line, if you draw a horizontal line, if this is alpha, the second will be pi minus alpha. So this is an example. If the first one is alpha, if you draw, the second one will be pi minus alpha. These two angles, if you project on the y-axis, they have the same sign. This is their sign. So that's why we say alpha plus 2k pi, or pi minus alpha plus 2k pi, or in degree 360k you put. Suppose I want to solve this one. So and this is the boundary. Sine x equal half. The sine will give me half is pi over 6, which is 30 degree. If I apply the property x equal pi over 6 plus 2k pi, or pi minus pi over 6. So if I do it, I have this one. Now I start by taking k. If k is 0, both are in the boundary. If k is 1, 2 pi plus pi over 6 or 2 pi plus 5 pi over 6, it's outside the boundary because bigger than 2 pi. If k is minus 1, you have pi over 6 minus 2k pi. This is minus 11 pi over 6. It's in the boundary, bigger than minus 2 pi. And if you put here minus 2 pi plus 5 over pi, 6, it's also in the boundary. For any angle 2 minus 2 for k, whatever, all angles will be rejected. Another example inside. This is an equation of second degree, but in sine, where a is 2, b, this is a, this is b, this is c. If you do delta or use your calculator, you're going to get two values. The first one is 1, and the second one minus radical 3 over 2. So I start solving the first one. Which sign will give me 1? You all know it's 90, so it's sine 90. So if I apply the property, you're going to get the angle inside, which is 3x minus 40 equal to 90, or 3x minus 40 equal 180 minus 90. Plus 360k, of course, because it's in degree. If you take the 40 to the other side, then you divide by 3, you're going to get this system. You can check it by yourself. Now you start taking k, so that it must be between minus 190, 180. If you take k to be 0 for both, it will be you can see here that these two are the same, so you can cancel one. No need to do for both because both equations are the same. If k is 0, you have 130 over 3. If k is 1, for 90 over 3, if you divide it, it will be in the boundary. However, for k is minus 1, it's also in the boundary. But if you take k to be 2 or minus 2 or whatever, all will be rejected. For the second one, you have minus radical 3 over 2. It's a remarkable angle. It's sine minus 60. So 3x minus 40 equal minus 60 plus 360k, or 180 minus alpha minus 60 is plus 60. You have that one. Now you start taking k. For k is 0, both are accepted. For k is 1, the first one is in the boundary, but the second one, 120 plus 283, is bigger than 180, so rejected. So here rejected. For k is minus 1, the first one is rejected. You can check it, minus 120 minus 20 over 3. It's before minus 90. And for k is minus 1, here it works. Now the last property is for tangent. When two tangents are equal when they are diametrically opposite. You know from before, tangent pi plus alpha, it was a property, equal tangent alpha. So that's why we say for tangent, it must be diametrically opposite. If this is alpha, from here till here, this will be pi plus alpha. So that's why we said x equal a plus k pi, or a plus 180k if it's in degree. So let us take this in application. Tangent x minus 40 is 1. So tangent 45 will give me 1. So x minus 40 equal 45. So x will be 80 plus 180k. So if you take k to be 0, you're going to get 85. 85 is not in the boundary between 100 and 200. It's rejected. So we go to k equal to 1. If k is equal to 1, you have 165. 165 is in the boundary, so it's accepted. If k is minus 1, you're going to get 85 minus 180, which is 95. 95 is not in the boundary, so I have only one solution, which is 165. I hope that you got this lesson, and see you tomorrow in school.